we are expecting to come down at your term 2 examination. Okay, so exercise numerical problem, that page I am telling you that 221, you may also 221, yes, 221 is the page number. So question number 11, 1 to 11 we have already done it successfully in our classes. So from 12 onwards today I am going to tell you. And first of all, before starting, I just want to remind you the useful formulas which we are taking, right? First formula, Ohm's law, you know it, V is equal to IR. V is equal to IR. Is it visible now? Okay, like that, right? V is equal to IR. Okay, you may like, yes, yes. So one is V is equal to IR, that is Ohm's law. It is very clear, right? And after that, in this way, or no, that is the way, na? Okay. Okay. And 1/4 is I is equal to Q by T, right? And V is equal to IR and V is equal to W by Q is also there. So there are two formulas for V, and I is equal to Q by T, and resistance is equal to rho, length of area and by area of cross section. So resistance is always comes in ohm, I is always comes in ampere, V is always comes in volt, right? So that is that figure, and that is that some formulas which I am going to remind you. And after that, P, that is power. Power is equal to actually V by I, VI. Okay, and when the series connection or parallel connection, series connection like that, series connection. In series connection, P please put I square R, and if it is parallel connection, then P is equal to V square by R. You please remember that formula for the power. For the power, V square by R will be applicable for the parallel connection, and I square into R is applicable for power that is in series connection, because here I is constant and here V is constant. That is why, right? So these are all the some useful formulas which I know that all of you are very well known. So I am starting question number 12 onwards, right? Page number 221. Please see. First of all, question number 12. Okay. Question number 12, that is several electric bulbs designed to be used on a 220 volt, that is 220 volt is given. Electric supply line are rated 10 watt. Matlab, the power of one bulb is 10 watt, right? Okay. How many lamps can be connected in parallel with each other across the 2 watts of 220 volt line if the maximum allowable current is 5 ampere? First of all, you just remember number of lamps. Only one formula, that is total power divided by unit power. That's all. That's all. Total power. The power is formula is VI, you know, VI. Our unit power is 10. It has already been given in your question paper. So power is VI, V is 220 and I is 5 ampere, VI, and that is 10 is unit power. So 0 cancel. So 22 into 5, that is 5 into 110. So number of lamps is 110 is your answer. Number of lamps is 110 is your answer. Hope it is clear. No doubt, right? Now question number 13 I am telling you. Question number 13, right? That question number 13. A hot plate of an electric oven connected to a 220 volt line has two resistance coils A and B. Two types of coil. One is coil A and other is coil B, right? And volt is of course 220 volt. Okay. So coil A and coil B, resistance coil A and B, each of 24 ohm resistance, each of 24 resistance ohm, and which may be used separately in series and in parallel also. So first of all, one is separately, okay? One is series connection, okay, and another is parallel connection. So there are three answers will be coming, and which may be in it. What are the current? Current is, current you know, that is V by R. Current is V by R. In all the three cases, current formula is the same, V by R. If it is separately and 24 ohm is there, so V is 220 volt, 220 divided by 24, that ampere. Here V is, that is series connection, so 24 plus 24, that is 48, है R is 48 and V of course 220. Just cancel it, that ampere is coming. And here is 24 ohm in series connection. One is 24, one is 24, like that. So 24 into 24 and 24 plus 12, 24. So 24 into 24 and 24 plus 24, that is 48. 212 there, 212 there. So V is 220 and R is 12. Whatever calculation will be coming, that will coming ampere. So in that three answers will be coming separately, series and parallel. Question given is, there are 24 coils, that is coil 1, coil A is 24, coil B is 24 ohm. Two resistance is there in series connection, right? And 220 volt is the V, the value of V. So of course I is V by R in all the three cases. You will get your answer very shortly. Formula is like the same, right? And question number 14 now. Question number 14, I am reading the question. Compare the power used in 2 ohm resistor in each of the following circuits. One is 6 volt battery in series with 1 ohm resistance and 2 ohm resistance. Matlab like that. Right? One is 1 ohm, one is 2 ohm, that is series connection. Okay? And 2 ohm resistor means you have to find that 2 ohm resistor in each of the following circuits, and 6 volt battery, that is the 6 volt battery, right? And another is 4 volt battery in parallel, 12 and 2. Okay, 12 and 2, that is 12 volt, that is 12 ohms, sorry, resistance is 12 ohm and that is 2 ohm, right? In this way, okay, and that is of course 4 volt battery. So there are two answers will be coming very shortly, right? Question is compare the power. I know that we know that power is I square R for the series connection, and power is V square by R in the parallel connection. That please note it down. To find out the power, you should apply that formula for the parallel connection, and if it is series connection, power formula is I square into R. Okay, I square, I is not here, but I can be calculated. I is V by R, V is how much? V is V is 6 volt. Okay, and R is of course 2. Okay, 2. So current is 3, right? Volt is 6 volt battery, na? 6 volt battery, and R is 2 plus 1 3. Sorry, I was 2 plus 1 3. So 6 divided by 3. Just a minute, I am repeating. V is 6. Okay, 6 volt, and R is series connection 1 plus 2, that is 3. So I is 2. So I square is 2 into 2, and R is resistance 2 ohm. So that is 8 watt power. Very easy. Another V square. V square is 4 volt. So 4 into 4, and resistance is your 2. So 2 to the, that is 8 also, na? V square by R, that is also 4 into 2, 8 watt. Okay, V square. V is 4 volt, na? 4 into 4, and R of course resistance is 2 ohm. It's 8 watt. And there is I is 2 into 2, and R is resistance is 2 ohm ka, that is 2 into 2 4 into 8, like that. Okay, that is question number 14 is over. Now question number 15 is 2 lamps, one rated 100 watt and the 220 volt. 2 lamps, first lamp and second lamp, right? So 100 watt power is 100 watt, and V is 220 volt, and here is P is 60 watt and V is 220 volt. Okay, 220 volt connected in parallel connection. Okay, and what current is drawn from the line if the supply voltage is 220 volt. Okay, so you know the formula, current है ना, current is equal to V by R, right? So V is there, no issue, but R we have to find out. So first of all, to find out the R, that is P is there. P is equal to power. Power is equal to, tell me the which formula we can calculate it. Power is equal to VI. Okay, power is equal to VI. So V is 220 and I is V by R. V by R. And okay, just a minute. Yeah, that is not the way, that is not the right way to tell it. Once again, power is 100 watt and V is 220 volt. Our question is what current is drawn from the line if the supply voltage is 220 volt. Okay, so formula is I is equal to V by R. Okay, that is the main formula. So while find out that V here, V is 220 and R is V by I, or R you can write the formula in case of P is equal to VI is also there, one formula is na. So power is 100, V is 220 and I is like that. So I is 100 by 220, that is I, right? and R is V by I. R is V by I. I is 100 by 220. V by I, so 220 is there and 100 is there. Whatever I will be coming, just calculate it. In this way that I is calculated over here also. Right? You can understand what I am telling. I is equal to V by R, that is the main formula to find out the question number 15. So V is given 220 volt, that is not issue. Regarding R, when you are find out R, so first of all R is V by I. So V is again no issue, V by I. So what is I? I is, in case of power is there, then P is equal to VI. So P is 100, V is 220, I is equal to 100 by 220 here. 100 by 220, right? In this one I is there, here is also I is there. That I is equal to then V by R is there. R what is R? V is 220 and R is V by I. Okay. So just put that formula, you will get your answer. Once again I am just repeating so you can get it better understand. Just a minute. 15. Okay. 100 watt power is 100 watt and V is 220 volt in line 1, and one is power is 60 watt and volt is 220 volt. Okay, that is okay. In parallel connection, all are parallel connection. Okay, parallel connection means 1 by R is equal to 1 by R1 plus 1 by R2, right? That you can understand. So 1 by R1, what is R? R is equal to V by I. Okay, so V is 220 and I is P is equal to VI. I is P by V. The power is 100 and P by V. V is again 220, right? In this way 0 0 0 0 cancel, that is 22 into 22, whatever it comes. $484. Okay, that is 484. That R1 is 484. In this way you just find out the value of R2 here. Then R1 plus R2 is the real R. Okay, then current is equal to V by V by R. So V is 220 and R of course you will get from here. You just put that value of here, you will get your answer. Okay, that is the 15 is also there. 16, which uses the more energy, that is 250 volt TV in 1 hour and 1200 watt toaster in 10 minutes. So one is TV, one is toaster. Okay, so TV is 250 volt. Okay, of course TV is 250 watt. TV is 250 watt and that is toaster is 1200. That is toaster is 1200 watt. Okay, here is 1 hour, time is 1 hour and here time is 10 minute. 10 minute matlab 10 by 60, that is hour, that is 1 by 6 hour, right? Now energy, which has the more energy, that energy is equal to PT. That energy is also PT, right? So P is 250 and T is 1 hour, so that is 250 joule. Energy is also incoming in joule, doesn't matter. and P is 1200 at time is 1/6, that is 200 joule. So that is the 250 joule is the more. 250 joule has the greater energy, right? So okay, there is the night times. Tomorrow we will sit again for class 10. In a fresh way in electricity I will tell you with some different formulas also. Okay, bye bye.